Let's practice finding the solutions of quadratic functions from all three different forms. The three forms that I'm referring to are going to be factored form, standard form, and vertex form. For each of these practice problems, let's just go ahead and sketch the graph for each one of them, and then we'll go ahead and determine the solutions for each of these functions. For number one, we have the function f of x is equal to the quantity of x minus 5 times the quantity of x plus 3. To get started on finding solutions, what we always want to do is just set y equal to 0, because when y is equal to 0, that's where we can find the x-intercepts. Alright, so we're setting 0 equal to the quantity of x minus 5 times the quantity of x plus 3. At this point, to solve this equation, the left side is equal to 0, so the right side has to somehow equal 0. The only way that can happen is if this is equal to 0, this binomial of x minus 5, or if this binomial is equal to 0 of x plus 3. So what would make each of these go to 0? Well, if we want to go ahead and do that, let's just take a look at the first one, and if we set it equal to 0, say x minus 5 is equal to 0, and then we just go ahead and add 5 to both sides of this equation, then we can easily see here that if x was equal to positive 5, then the whole right side would become 0. On the other hand, if we take a look at this x plus 3, and we set that equal to 0, and if we solve it, we can find out that we subtract 3 from both sides of the equation. Then if x was equal to negative 3, then that binomial would become 0, and the whole right side of the equation would also become 0. Based on this, we know that one of the x-intercepts is going to be 5, 0, and the other x-intercept is going to be negative 3, 0. If we're going ahead and writing the solution set for this equation, the two solutions that make this equation true are going to be 5 and negative 3. Alright, so this is just another way of writing our solutions to this equation, which are really just the x-intercepts. Now let's go ahead and make a rough sketch. Here we have an xy plane, and I'm just going to go ahead and go 1, 2, 3, 4, 5 units to the right, and go ahead and put one of our x-intercepts over here. Let me make that a little darker here. And that's going to be at 5, 0, so that's going to be one of our solutions. And then for the other one, we have negative 3, so let's move 3 units to the left here, and go ahead and put a point. That would be the other x-intercept we have here, okay? Now, given these 2 points, it's important to note that you can see that one of them is 5, one of them is negative 3, and they're 8 apart from each other. So exactly halfway between would be 4 away from each one of those. And so when x equals 1, we would have our AOS. So keep in mind that the equation for the AOS is always going to be the average of the two solutions, or the two x-intercepts. So the average of 5 and negative 3 is positive 1. Now, I'm not drawing the most detailed graph here, but please know that since a is equal to positive 1, or we have a leading coefficient of 1 in front of the parentheses, we know that we have a minimum and the parabola is going to open up. For those reasons, we know that our parabola is going to be opening upwards. This would be the rough sketch of a parabola for this given quadratic function. For number 2, we have the function f of x is equal to x times the quantity of x minus 6. So again, if we want to find the solutions first, we set the left side equal to 0, or y equal to 0, so we have 0 is equal to x times the quantity of x minus 6. Okay, so this is technically already factored. We have a monomial multiplied by a binomial here, and so if we want to find out where the solutions are, or how do we make the right side equal to the left side of 0, then this x over here, x would have to equal 0, so that's actually not a lot of work. We already know that has to be what it is. And then for the second one, this binomial, in order for this to equal 0, we can set it equal to 0, say x minus 6 is equal to 0, add 6 to both sides of the equation here, and we can see here that if x was equal to positive 6, then the whole function would equal 0, right? So these are going to be our two solutions. We know one x-intercept is going to be 0, 0, it's right at the origin, and the second x-intercept is going to be positive 6, 0. So those would be the two x-intercepts, and if you wanted to write this using a solution set, we can say that one of the solutions is going to be 0, and the second solution here is going to be positive 6. So those would be the two solutions here. Now let's make a rough sketch of a graph. Here's our xy plane, and we need to go up to 6, so maybe 1, 2, 3, 4, 5, and 6. One of our solutions is 0, 0. That's right at the origin, so we can put that over here. And our other one is going to be 6, 0, so it's on the positive x-axis located right about here. Now, if you want to just draw the AOS quickly, just to get used to it, it's going to be the average of this 0 and 6, so between 0 and 6 is going to be 3. So let's go ahead and sketch the AOS just so we see where it is. Alrighty, so here is the AOS. The AOS is going to be the equation x is equal to positive 3. So 3 would be the x value for the vertex, and you could plug that into the function to get the y value, but I'm not going to do that in this particular video. Now sketching the parabola, it's going to look something like this. Because we know our a value, or leading coefficient, is equal to positive 1, we know it's going to open upwards and we have a minimum. Let's try number 3. For number 3, we don't have a factored form function here. Instead, we have one that is written in standard form. So same procedure. If we want to find out where it crosses the x-axis or find the solutions, what we're going to do is we're going to set it equal to 0, right? So when y is equal to 0, then that's where the x-intercepts are going to occur. All right, so if we want to go ahead and see if we can factor this thing, our leading coefficient is going to be 1, so I'm going to write 1 and 1. We know that they both have to be 1s in terms of the coefficients for the x, and then we have to think of two numbers that multiply to get to this negative 35, but are 2 apart. Okay, so I'm going to go with 7 and 5. Okay, because 7 times 5 is 35. And because we have a negative 2, right, we have a negative 2 here, I'm going to go with a negative 7 as opposed to negative 5, right? So if we go ahead and pair up these two values of 1 and negative 7, 1 times negative 7 is negative 7, and 1 times positive 5 is positive 5. Negative 7 plus 5 is indeed negative 2. So if we go ahead and open up and write the factored form here, these are my two binomials I'm opening up. Right, we do know that we're going to have x and x, 1x and 1x, those were the two coefficients. And then for these ones that paired up as 1 and negative 7, I'm going to pair those up as my outers, right? You should always pair them up as their outers or the inners. So I'm going to go ahead and write minus 7. And then for the other pair here of 1x and positive 5, we already have the 1x. Let's just go ahead and put the positive 5 here. Okay, so keep in mind that this 1 and negative 7, you pair them up like this, and then this 1 and positive 5, you pair them up like this. So they always pair as outers and inners. Now that we have this quadratic equation in factored form, it's going to be easier to find the solution. So let's see, what makes this equal 0? So we set x plus 5 equal to 0. If we go ahead and take away 5 from the left side, take away 5 from the right side, using that subtraction property of equality, we can see that if x was equal to negative 5, then the whole right side would equal 0. And then looking at this binomial of x minus 7, if we set that equal to 0, and we go ahead and add 7 to both sides, we can see that the value of x equals positive 7 would make that binomial equal 0, and then the whole right side of the equation equal 0 as well. So the fact that x equals negative 5 is one of our solutions. We can say negative 5 comma 0 would be one of our x-intercepts, and then positive 7 comma 0 would be our other one. And using a solution set notation, we can say that negative 5 is going to be one of the solutions, and then positive 7 is the other. So hopefully that notation is getting a little bit more clear. This is just one way of writing our solutions. Now for a sketch. Here is our XY plane, and we need to move 5 units to the left, maybe like 1, 2, 3, 4, 5, and 7 units to the right, 1, 2, 3, 4, 5, 6, 7. Again, this is just a very rough sketch, so if you have graph paper, that would be more ideal in terms of drawing a more accurate sketch. So here's one solution, and here is our second solution. Okay. In terms of where the AOS would be, well, this is negative 5 and positive 7. So those are 12 apart. So halfway would be 6 apart. So 7 minus 6 is 1, or negative 5 plus 6 is 1. So our AOS will be at x equals 1. So I know it is a little bit on the smaller side, but x equals 1 is where that middle line would be, and that's going to be the x value for the vertex as well. And so because we have our a value of positive 1, we know this is going to open up again. And so we know, roughly speaking, that our parabola would open up and look maybe something like this. All right, for number 4, we have this function f of x is equal to x squared minus 25. So you could consider this maybe in vertex form as well, or standard form, just because there's no b term, but hopefully this one does look familiar. If we want to find the solutions, again, set y equal to 0 or f of x, and so we have 0 is equal to x squared minus 25. Now, if you do recognize this special case, then that's wonderful, because then you can just factor it into the quantity of x plus 5 and then the quantity of x minus 5, because it's a difference of squares, right? And so if you know it's a difference of squares, then you can factor much quicker. And setting this equal to 0, you can find out one of the solutions. So x plus 5 equals 0. Take away 5, take away 5. And hopefully you notice something interesting that will happen with all difference of squares patterns, but I'll go ahead and do this part first. So one of the solutions is x equals negative 5, and then we'll set this one equal to 0. go ahead and add 5 to both sides. And then we find out that x is equal to positive 5, right? So when you have difference of squares patterns, the solutions are always going to be opposites of each other, right? So that's going to happen each and every single time. It's just basically a vertical shift down 25 units in this case from the origin. So one of our solutions is going to be negative 5, 0. And the other solution is going to be the opposite, and it's going to be positive 5, 0. So you're going to see that the AOS is always going to line up on the y-axis when you have difference of squares patterns. In terms of our solution set, one of the solutions we're going to say is negative 5. For the other solutions, we're going to say positive 5, just like this. Now to graph it, we're going to go ahead and just move 5 units to the left, 1, 2, 3, 4, 5, something like that. And then 5 units to the right, 1, 2, 3, 4, and 5. Let's go ahead and put one point at negative 5, 0, and another point at positive 5, 0. And the AOS is going to be right on the y-axis. Hopefully that makes sense that halfway between negative 5 and positive 5 is exactly 0. So we know the vertex is going to be 0, negative 25 actually, just because the k value in vertex form would be negative 25. Now since a is equal to 1, we know this is going to open upwards. And so roughly this would be the parabola for this quadratic function. If you can remember that difference of squares patterns always looks like this, it's basically just a vertical shift up or down, never left and right. I think that could help you save some time and know your solutions are always going to be opposites. Here's number 5. For number 5, we have the function f of x is equal to x squared plus 8x plus 16. So if we want to find the solutions, let's set f of x or y equal to 0 to find those x-intercepts. And then let's try to see if we can factor this. Now, you can go ahead and factor and write like you have 1 and 1 since a is equal to 1. That's kind of nice. And then I think we're going to use positive 4 and positive 4 because 4 times 4 is 16. And then 4 plus 4 will equal 8. But you also just want to kind of notice here that this is a perfect square trinomial, right? So if you were like completing the square or something like that, that this would be 2 of the identical binomials, and this is going to be interesting as well. So if we go ahead and factor this, right, it's going to turn into the quantity of x plus 4 times the quantity of x plus 4. And the way you can kind of identify those in the future is if you notice that's a perfect square and that's a perfect square, then the square root of this is just x, and the square root of this is 4. And if you multiply these two together, you will get 4x, right? And if you double this, right, if you times it by 2 and you get 8x, which is the middle, then you know that this is a perfect square trinomial. So if you can identify that, then you know you're always going to have 2 identical binomials. Okay, so in this case, we do have this special case, and so we can factor this and say this is going to be the quantity of x plus 4 squared is equal to 0, right? It's 2 of the same binomial. So you're actually only going to have one solution for these types. So we're going to go ahead and say what makes this equal to 0? We have x plus 4 equals 0. You can take away 4 from both sides here. And when you do that, you find out that x is equal to negative 4. So the solution here is going to be negative 4, 0. All right, that's it. For the solution set, you're only going to have one solution, so we can just put this negative 4 in the middle, or just inside the braces rather, and that's the one solution. So whenever you have perfect square trinomials, we just have one solution. To sketch a graph here, we just need to move to the left 4 units, so 1, 2, 3, and 4. Let's put our point, that's going to be our solution or our x-intercept, and our AOS is just going to be at the same location as well. Hopefully that makes sense that halfway between negative 4 and itself is just itself, right? So the AOS is going to be right on that solution as well. In terms of the graph, since a is equal to 1 or positive 1, right, that's that leading coefficient, we know this is going to open upwards, and the graph can only touch the x-axis at that solution. It can't go through it. So whenever you have perfect square trinomials, be on the lookout for this because it doesn't go through the x-axis. It just comes down and touches the x-axis at the solution, and then it comes back up or goes back down if you had a negative a value or negative leading coefficient. So again, this was just one more of those special cases, so be on the lookout for these in the future. Alright, let's check out number 6. For number 6, we have a standard form equation. Now keep in mind from the beginning that a is equal to 2 instead of 1, so factoring is going to be a little bit more work in this case. So we have 0 is equal to 2x squared. Again, we're setting it equal to 0 because we're solving for the x-intercepts, where y has to equal 0. And we can go ahead and factor this. We know it's going to be 2 and 1 because 2 is prime. Now we have to find two numbers that multiply to negative 15 now. I'm just going to start with a 5 and a 3 and then go from there. Okay, now I'm thinking here that the 3 has to be negative, because see what's going to happen here. Ready? 2 and 5 are going to make 10, and then 1 and negative 3 are going to make negative 3. So if you compare these up, that's 10, take away 3, and that does equal 7 in the middle. So that helps us find our binomial. So I'm going to say 0 is equal to, open up these binomials, and we know that one of them is going to be 2x, and then the plus 5 is going to be the outers. And then the other one's going to be x, and then this minus 3 is located here. So keep in mind that this 2 and this 5 that pair up, those are the outers, and then this 1 and negative 3 are going to be our inners, okay? So make sure you're being careful of that. If you FOIL this out, we should get the original. Now, let's go ahead and see how this binomial is equal to 0. So if we take this 2x minus 3, set it equal to 0, let's go ahead and add 3 to both sides of the equation. We can see here that 2x would be equal to positive 3. Then divide both sides by 2. We can see that here that x is equal to 3 halves. Or 1.5, right? That would be fine as well. And then for the second one, this one's a little bit less work, just because we don't have a coefficient or a value in front of the x besides 1. So x plus 5 equals 0. We can take away 5, and if we do that, we see that x equals negative 5. Right? So one of the solutions is going to be 3 halves comma 0, or rather we call that the x-intercept, and the second one is going to be negative 5 comma 0. And for our solution set, we know that 3 halves is going to be one of the values for x that makes this whole thing equal 0, and the other solution is going to be negative 5. So those are the two values of x that make this equation true, or where it crosses the x-axis. Now let's sketch a graph. So to go 5 units to the left, maybe 1, 2, 3, 4, and 5. And then we have to go a couple units to the right, so 1 and 2. I don't need to go past there just because this first one is going to be 3 halves, which is 1.5. So it's going to be between 1 and 2 here. Okay, something just like this. And then negative 5 comma 0 is roughly over here. Now, what's between 1.5 and 5? Negative 5? Well, between 1.5 and negative 5, that's 6.5 apart. So what's half of 6.5? That's 3.25, okay? So if you go 3.25 down or 3.25 up, we should get our AOS. So 3.25 to the right of negative 5 would be negative 1 3/4, right? So I'm gonna try to estimate the AOS to be negative 1 3/4. So roughly here, that would be the sketch, but x equals negative 1 3/4 or negative 7/4. That should be right smack in the middle. So again, if you wanted to check this algebraically and just see what the average of these are, you would just take the two numbers, 3/2 plus negative 5 is the same thing as negative 10/2. And so that's going to be negative 7/2. And if you divided that by 2, that's the same thing as multiplying by its reciprocal. So that'd be negative 7/4, which again is negative 1 3/4. All right, so that would be right in the middle. Because 2 is positive, our leading coefficient, we know this opens upwards and we have a minimum. So roughly sketching this, this is what the parabola would look like. Here's number 7. So for number 7, notice how we have this whole thing written in vertex form. So that's useful, that's nice and all for the vertex, but we're not looking for the vertex, right? So we do know the vertex is going to be h comma k, and that's going to be, in this case, negative 2 comma negative 36, but it doesn't help with the solutions, right? So if you want to find the solution, still set the whole thing equal to 0. And while you're at it, let's just go ahead and expand this and say x plus 2 times x plus 2, and then write minus 36, right? Okay, so now that we have this, what we're gonna do is just FOIL this out or multiply it out. So we're gonna go ahead and do first, outer, inner, last, and just multiply all these. The middle terms are gonna combine, so x times x will have x squared. Then we're gonna get 2x on the outers and 2x on the inners to get positive 4x. 2 times 2 is gonna be 4, and then we have a minus 36, okay? Now let's go ahead and just take this 4 and minus 36. Those can be combined because they're both constants. And so let's go and say 0 equals x squared plus 4x, and then minus 32. All right, now at this point, we should see if we can maybe factor this, right? And so we know that the leading coefficient here is 1, so we're gonna have 1x and 1x. And two numbers that multiply to get to negative 32, I'm gonna say 8 and 4, and make the 4 negative, right? So if we go ahead and multiply across, this would be 8, and then this would be negative 4, and 8 minus 4 does equal positive 4. So going ahead and writing this in factored form, we have our binomials now. We can open these binomials up. and we're going to have x and then plus 8 for our outers, and then x minus 4 for our inners. So again, if you're still getting used to this, these two are paired up as our outers, and these two are paired up as our inners. And if you'd like to FOIL this to check, this should equal what we started with here in standard form. Now to find our solutions, we can set this equal to 0. So we have x minus 4 equals 0. We can add 4 and add 4, and we can find out that when x is equal to 4, this whole thing will equal 0 on the right side. And setting this equal to 0, if we say x plus 8 is equal to 0, if we take away 8, and say that x is equal to negative 8, that would be another solution. All right, so writing the intercepts, we could say that 4 comma 0, that would be one of the x-intercepts, and a negative 8 comma 0 would be the other intercept. Writing solutions, it would look like this. We would say 4 would be one of the solutions, and then negative 8 would be the other solution. All right, so those would be the solutions, or the x-intercepts, for this quadratic function. All right, now for a graph, we need to go 8 units to the left. So 1, 2, 3, 4, 5, 6, 7, and 8 units to the left, and then 4 units to the right. 1, 2, 3, and 4. So let's go ahead and put negative 8 all the way along the negative x-axis here. So negative 8 looks like roughly, and then positive 4 would be over here. Now, what's between 4 and negative 8? It looks like they're 12 apart. So half of 12 is 6. So we can either go 6 down from 4 or 6 up from negative 8. Either way, we're going to get negative 2 for the AOS. Going ahead and just putting this in, so we say x equals negative 2. And this hopefully should make sense because this negative 2 is basically what we're told here, that the vertex would be at negative 2, right? So that should help us out. And so while this is not drawn to scale, this would be a rough sketch of the parabola. Since we know that a is equal to 1, it does open upwards. And I know this isn't really 36 units down, but that's technically what it would be if you scaled this appropriately. And we know this is open upwards just because a is equal to 1, so the vertex should be right over here. I know this isn't to scale and 36 units down, but technically that's where it would be if you drew it more accurately. If you had a graphing calculator or Desmos or something like that, or if you had graph paper, it should be 36 units down. All right, finally we have one more for number 8. We have f of x is equal to the quantity of x minus 3 squared minus 25. Again, this is in vertex form, so right away we do know that the vertex h comma k is going to be equal to positive 3, negative 25. So we know the AOS is going to be at x equals 3, but that's besides the point. We're looking for solutions here, right? So let's go ahead and say 0 is equal to, let's go ahead and expand this. So it's the quantity of x minus 3 times the quantity of x minus 3, and then minus 25 afterwards. Okay, let's go ahead and multiply x times x, which is x squared. This would be negative 3x, another negative 3x, and then a positive 9. So if we go ahead and write that out, we're going to have x squared, and then minus 3x makes negative 6x, and then negative 3 times negative 3 is positive 9, and then we're going to take away 25. Now we can combine these like terms, these constants at the end, and say 0 is equal to x squared, then minus 6x, and then minus 16. All right, so at this point, this is a quadratic written in standard form, and so we can maybe factor this. So we have a leading coefficient of 1, so we know it's 1 and 1 if we can factor it. And then for 16, I'm thinking 8 and 2, right? And I'm thinking of the negative 8 here. So if we did 1 times negative 8, that's negative 8. 1 times 2, it's positive 2. So if we had negative 8 and positive 2, combine that, we do get negative 6. So we have our two binomials here. So we could say 0 is equal to, and then open up these two binomials and then place our pieces in. So the outers are going to be x and then minus 8, and their inners are going to be x and then plus 2. So again, this x, this 1x and negative 8, those are outers, and then the 1x and positive 2, those are inners. And if you FOIL or multiply this out, you will get this standard form that we just had a moment ago. All right, setting this equal to 0 to find our solution. If we say x plus 2 is equal to 0, if we take away 2, we can see here that x is equal to negative 2. That would be one of our solutions. And for the second one, x minus 8, if that's equal to 0, then x would have to equal positive 8. All right, so those would be our two solutions. One of our intercepts is going to be negative 2 comma 0. Our other solutions is going to be positive 8 comma 0. So our solution set is going to be negative 2 comma positive 8. And here's a quick sketch. We're gonna have to go 2 units to the left, so maybe something like this, and then we'll go 8 units to the right. 1, 2, 3, 4, 5, 6, 7, and 8. And we can go ahead and plot our points down. So -2, 0, right about here, and +8, 0, right over here. Now to see where AOS would be, we can go halfway between these. So these are 10 apart from each other. Half of 10 is 5. So 5 less than 8 is 3, or 5 more than -2 is also 3. Or you can see here that from vertex form, we knew it was 3 all along. Right over here, x equals 3, that would be our AOS. And our parabola would look something like this. Again, all of them in this practice set of problems, all 8 of these had a value of positive, so it's going to open upwards. This vertex at the bottom is 3 units to the right, which is what we had over here, and it should be 25 units down. Again, I know it's not drawn to scale, but hopefully you get the point, and you kind of understand a little better that the x-intercepts or the roots or the zeros, all kind of different ways of saying the same thing in different ways, but these would be the 2 solutions or the zeros of this quadratic function. All right, so here you have 8 different practice problems, a few of them in standard form, a few in factored form, a few in vertex form, and so hopefully you feel a little bit better about finding solutions of these. All right, so if you found this video helpful, please consider giving it a thumbs up. Again, you can find a blank copy of this PDF and a detailed written answer key as well using the description box below. And as always, keep up the great work, and I'll see you in the next one.